Mathematical induction, how to start. What is it? Mathematical induction is a mathematical technique which is used to prove a statement. Why? Helps conclude infinitely many statements are true by checking on two things. Interesting fact. Polar bears have an excellent sense of smell, with the ability to detect seals nearly 1 mile or 1.6 kilometers away. Now, let's take a look at the principle of mathematical induction. It states, if with each positive integer n, there's a statement, p sub n, then all statements p sub n are true, if the following are true. Statement 1, p sub n is true, and statement 2, whenever k is a positive integer such that p sub k is true, then p sub k plus 1 is also true. Now, let's show the steps in applying the principle of mathematical induction. We have two steps. The first step is show that p sub 1 is true, and the second step is assume that p sub k is true, and then prove that p sub k plus 1 is true. Now, let's take a look at the example that we're going to be talking about in today's video. Since we only have one, let's go ahead and read the steps. Step 1, show that p sub 1 is true. Step 2, prove p sub k plus 1 is true. Now, let's read the question. Use mathematical induction to prove that for every integer n, the sum of the first n positive integers is n times the quantity of n plus 1 divided by 2. Sometimes with mathematical induction, we have to create an equation with the information that they give us. This is one of those cases. So if n is a positive integer, let p sub n denote the statement 1 plus 2 plus 3 plus dot 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 plus n is equal to n times the quantity of n plus 1 divided by 2. Where did the statement come from? Well, let's take a look at p sub 1, where we have substituted 1 for all the n's. And now we have 1 is equal to 1 times the quantity of 1 plus 1 divided by 2. Now, let's simplify by adding the numbers inside the parentheses, and 1 plus 1 is 2. Now, let's multiply the numbers in the numerator. 1 times 2 is 2, and 2 divided by 2 is 1. So we have 1 is equal to 1. What does this mean? Well, we only have one positive integer, which is 1 in this case. The sum of that integer is 1. Now let's see what happens when we have p sub 2, where we substitute 2 for every n that we see. Now we have 1 plus 2 is equal to 2 times the quantity of 2 plus 1 divided by 2. Let's simplify the left side of the equal sign by adding 1 plus 2, and the result is 3. Let's also simplify the numbers inside the parentheses, and 2 plus 1 is 3. Now, let's multiply the two numbers in the numerator, and 2 times 3 is 6, and 6 divided by 2 is 3. So 3 is equal to 3. What does this mean? Well, if we add the first two positive integers, 1 and 2, the result will be 3. Now, let's take a look at p sub 3, where we have substituted 3 for every n that we see. And now we have 1 plus 2 plus 3 is equal to 3 times the quantity of 3 plus 1 divided by 2. Now, let's simplify by adding the numbers on the left side of the equal sign, and 1 plus 2 plus 3 is 6. And now let's simplify by adding the numbers inside the parentheses, and 3 plus 1 is 4. Now, let's multiply the numbers in the numerator, and 3 times 4 is 12, and 12 divided by 2 is 6. Now we have 6 is equal to 6. What does this mean? Well, if we add the first three positive integers, 1 plus 2 plus 3, the sum will be 6. What do you think p sub 4 will be? Now sometimes with an example like this, we need to do a few examples to see what we're trying to prove. Luckily for us, we've already done step 1 by doing p sub 1. Now we need to do step 2 and prove p sub k plus 1 is true. Let's move on to step 2, where we assume p sub 1 is true. We've already substituted the k's into our statement, and now we have 1 plus 2 plus 3 plus dot 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 plus k is equal to k times the quantity of k plus 1 divided by 2. Let's write down our goal so we know what we are trying to achieve. We want 1 plus 2 plus 3 plus dot 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 plus k plus the quantity of k plus 1 is equal to the quantity of k plus 1 times the bracket of the quantity of k plus 1 plus 1 divided by 2. Let's take a look at the differences between what we assumed and our goal. On the left side of the equal sign of our goal, we have k and the quantity of k plus 1. And the reason for that is k is the previous term of the quantity of k plus 1. On the right side of our equal sign, we have substituted k plus 1 into our original statement instead of k. Now let's start step 2 and keep in mind our goal. We have 1 plus 2 plus 3 plus dot 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 plus k plus the quantity of k plus 1. Now we're going to use our assumption. Why do you think that is? Well, we're going to put parentheses around the first few terms because we know what 1 plus 2 plus 3 plus dot 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 plus k is equal to. And that is equal to k times the quantity of k plus 1 divided by 2. Remember, our induction hypothesis is 1 plus 2 plus 3 plus dot 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 plus k is equal to k times the quantity of k plus 1 divided by 2. Now, let's move on to our next step. If we remember our goal, we only have one fraction. So let's manipulate what we have so we can make it one fraction. So we found a common denominator, which is 2, and multiplied the second quantity of k plus 1 by 2 over 2, which is 1. Now, let's group these two fractions together since they have a common denominator of 2. Now, we're going to factor out a k plus 1 since there's a k plus 1 on the left side of the plus sign and on the right side of the plus sign. Now, if you don't see that, that's okay. You can distribute what you have and then factor out the resultant trinomial, or you can use the quadratic formula. All three ways will lead us to our goal, so it doesn't matter which method you use. Now, we only have one more step. What do you think it is? Well, we have to rewrite k plus 2 as a quantity of k plus 1 plus 1. We have our goal, so we have finished step 2. Now, let's go back to where we can see step 1 and step 2 together. We have shown that p sub 1 is true, and we have proven p sub k plus 1 is true. Therefore, this shows p sub k plus 1 is true by mathematical induction. This is our answer for example 1. Now, it is your turn, so go ahead, pause the video here, so you can take your time to answer this question, and I'll show you the steps and the result in 3, 2, and 1. Here's the first step, and what we have assumed and the goal for step 2. Here are the steps for step 2, and we have step 1 and step 2 together. Did you get it correct? Superb. If not, there's always tomorrow.